This is the finals review packet for Unit 3 help video. Taking a look at the first problem, there's going to be two variations of a problem like this. Both of them dealing with isosceles triangles. When you have two equal sides, you have two equal angles. So one variation of this problem is that you will have an equation here and another equation here. And in this case, if you have two equal sides, these angles are congruent. So you would do angle equals angle. Another variation would be as if you have an equation here and an equation up here. The trick to this problem is understanding, first off, the green and the red are not equal here, but you can repeat the equation for the red over here as well, because two equal sides, two equal angles. So in this case, it would be the red equation plus the red equation plus the green equation equals 180. So there's two variations going on here. Let's see which variation is an example in this one. Angle W we are given is 5x minus 10, and x is 3x plus 16. We want to find the measure of all three angles. So in this case, these two angles are congruent because you have two equal sides. So this is an example of the first. So angle equals angle, and then you solve. Don't get happy when you stop with x. You want to plug it in. So over here, 5 times 13 that gets you 65. And then 3 times 13 plus 16 also gets you 65. Then that's 130, take away from 180, and that gets you your third angle, which is 50. Problem 2. Here we're told that line L and M are parallel. Find the value of x. The most important thing to watch out for with parallel lines is armpits of the Z. So if that's 60, that's 60. And then you can add 65 plus the 60, take that away from 180, that means this angle here is 55. We're going to go for x, that's a linear pair, and that's 125. So whenever you have parallel lines, watch out for armpits of the Z, going both directions. Technically, there's one going this way as well. Number 3. Number 3 is going to ask you just for the value of x, but never just solve for x. Always look at your diagram and ask yourself, what do you know? And in this triangle, what you know is if you have 2 equal sides, you have 2 equal angles. So that 28 pulls over. We add those, take it away from 180. You get 124. There's your linear pair. That means this becomes 56. Then looking at this triangle right here, 2 equal sides, 2 equal angles. 56, 56.
I think I found a typo, but it's nothing major.
Add those two together, and you, of course, get 112. Take it away from 180. And we finally get what you were looking for was 68. So the key to find what you're looking for is not to look what you're looking for and just find everything else. Number 4, the property being demonstrated here is the fact that an exterior angle is equal to the sum of the 2 remote interior angles. So the remote interior angles add up to that exterior angle. So in this case, 36 plus 106 adds up to this exterior angle, which of course is 142. Now another way you could have done it is solved for this green angle first and then take it away from 180, and you're going to get the same problem. So problem 5 is an example of another variation that I warned you about of these 2 triangles. So taking a look here at number 5, if we have 2 equal sides, you have 2 equal angles. So in this case, these 2 angles are equal. So if this angle is 4x minus 9, this angle must also be 4x minus 9. And then we're given this is 2x plus 48. So your thing equation is angle plus angle plus angle equals 180. So in this case, it'd be 4x minus 9 plus 4x minus 9 plus 2x plus 48 equals 180, and you solve. Now do not stop with x. You always take the value of x. It wants the degree measure of each angle, so you're going to plug x back in and see what happens. So 4 times 15 is 60 minus 9. That would make this 51, which means this is 51. And this is going to be 78. And it's very easy to check by adding those up and see if they add it to 180, which they do.
You're muted, Mr. Way.
Okay, in this problem it says J, K, and L are all midpoints. So if they're midpoints, this is what you need to remember. This is a midpoint of that way. This is a midpoint this way. This is a midpoint here. So that means we have 3 mid-segments. One here, one here, one there. Those are all mid-segments. The basic rule is whenever you connect 2 midpoints of a triangle, 2 sides of a triangle, that mid-segment is parallel to the third side. It's also half. So if this was 10, this would be 5. So the mid-segment is both parallel and half the length. So in this diagram, we are told that JK is 38. JK is 38. And we're told that XZ is 96. And we're told YX is 56. And you're being asked to find certain lengths. Don't bother just finding certain lengths, just find everything. So again, it's a 2-to-1 ratio. So if this is 38, that's the mid-segment, you double it to get this. So it's 76. If this is 56, out here you divide by 2 to get that. Which is 28. And then the 96, to get this, again, you divide by 2, which is 48. Once you find everything, then you can just fill in the 3 blanks and you'll already have your answer. There are 4 triangle guts you need to be familiar with, 4 of them. So I'm going to draw 4 triangles here for you. So a median connects vertex to the opposite midpoint. That's a median. That's a median. An altitude connects vertex to a right angle. Perpendicular bisector goes through the midpoint at a perpendicular. And then an angle bisector cuts an angle in half. Those are your 4 triangle guts. So coming over here, you ask yourself, what do you notice? With the hatch mark, that makes that a midpoint, so it is a median. This one, note, it's at a right angle and through the midpoint. That is a perpendicular bisector. Vertex to a right angle, that's an altitude. We have 3 medians here, which means this is a centroid. The most important relationship here is the fact that it is a 1 bunny hop and 2 bunny hop relationship. So in this case, we're given Q to V is 10, which would make this 5. We're given R to S is 39, the whole thing. That means 1, 2, 3 bunny hops is 39. So we're going to divide by 3. That means this is 13 and this is 26. And then VT is 10, which makes this length right here 20. Once you establish your relationship all around, then it's super easy to find these. It says P to V, we already found it, is 20. Q to U is going to be the entire segment, which is 15. And then V to S, we already found that, that is 13. Alrighty guys, I'm going to check in. So in this last one, what you want to follow is gift, given, implied, freebies, and then think it through. So step 1, we're going to put the given on the diagram. ST and UT are congruent. That gets us a pair of sides. And RS and RU are also congruent. Gets you another pair of sides, so we're done. Implied and freebies. You have a reflexive side down the middle, so there's your third side. So I can see right now that these triangles are congruent by side, side, side. So on Alex, this is what it's going to look like. Step 1 is you'd put your first side in. Make sure you use the segment bar, the congruent sign, and segment bar. And you would click the reason is, it is given. Then you can put your other side in. RS, segment bar there, and RU, segment bar. And when you do this, there's an icon that looks like this in the margin in the toolbar, something equal to congruent to something. Grab that first and plunk it in and then type your stuff in. And that is given. Then we're going to write TR is congruent to TR. And the reason would be reflexive property. Then you can send a proof, and in this case, triangle RST is congruent to triangle RUT, and the reason is side, side, side. Let's follow GIF for this last problem. Given, implied, freebies, talk it through. So we are told here that side QR and ST, QR, ST, there's a side. PQR, the angle, is congruent to TSR, TSR, the angle. There's a pair of angles. And then you're done with your given. Implied and freebies. What's implied here would be that these vertical angles are congruent. You have to use 3 letters to name those in Alex, so we're going to go like this. RS is congruent to PRQ. That would give us an angle, and you look very carefully. The side is sandwiched between the two angles. So this spells angle, side angle. Actually, I would start with the angle here, so you follow angle, side angle. Angle, side, angle. So send to proof. Send to proof. And Alex, you would do that. And the vertical angles, you would grab the something's congruent to something icon. It looks like this. And we would write angle PRQ is congruent to angle TRS, vertical. And then send to proof. Triangle PQR is congruent to triangle TSR. And the reason is angle, side, angle.